Hello everybody. Previous video we showed the basic idea of AI, actually where the AI come from. It's actually statistical regression is the closest one, and also there was a method of making a decision in the marketing theory, and also there are many ways to help making a decision. And basically what AI is something that help you to make a decision based on the data, okay, the real data. So that's what it is. We considered one good example here. Suppose there is a farmhouse and a mathematician living there, and somehow he started farming and has a pond in front and a field for agriculture, and every morning he listened to the frogs croaking, and sometimes it's very noisy, sometimes very quiet. Eventually he noticed there is a correlation between frog croaking sounds, noise levels, and rain. And the rain is very important information for farmer. If it's rain, they have to do something else, cannot do field work too much, because heavy rains, nothing goes well in the field and he get wet. He doesn't want to do that. So in the morning he listened to frogs croaking and use the level of noise, how much frog croak, and this is the noise level. Let's say level 10, 20, 30. Then he observe if that day is rain or not, and this number of hours rain. So he see this positive correlation. If frog is quiet, almost no rain. Okay, so using regression, he's a mathematician, he knows how to take a regression, came up with equation. So suppose this noise level is X, so Wx plus B is going to be Y. Y is hours raining, and sometimes its value is negative, but still in reality it's statistical. So sometimes you get some rain, but sometimes he thought it's going to be rain because noise level is 20, but occasionally here rain didn't come. So that kind of things happen. But this is a pretty good equation to predict whether that day is going to be rain or not. So in the morning he listened to frog croaking and checked the noise level, and using this equation he get the Y, which is number of hours rain that day, and that's going to help him to make a decision what to do today in the farming. Okay, so decision making, this is kind of very simple AI model. Okay, you give X, then AI tell you Y, means noise level. What is today's frog's noise level? It's X. Then you get number of hours rain. Okay, so it's kind of a predictor of what happened today, and that predictor help to make a decision, right? Okay, now this frog and rain relationship, somewhat positive correlation, but it's not that accurate. Sometimes it's supposed to rain, it doesn't rain stuff. This he thought maybe some more things he need to observe to predict the rain more accurately. Okay, so what he did is he prepared the 10 different level of slide glass, and he looked at the sky, and if sky is bright, dark slide glass, he can see the pattern. But the sky is dark, then he doesn't see anything. So he got another correlation here. The sky's darkness. Sky's darkness. Darkness increase. Darkness is 0. 0 means very dark. There are some light is 10, and between 0 and 10, that are between 5, darkness medium. So when darkness is bright, probably number of rain is going to, it's not likely rain. So he observed that every day for 1 year, and he made this statistical model, correlation model, right? And that means this regression shows negative correlation. Negative correlation. Okay, it's positive correlation, negative correlation. So if sky is bright, which is 10, a lot of light, then probably it's not gonna rain. When sky is dark, overcast, right, then most likely it's rain. So he has two different input. Say this one x1 and this is x2, right? So what he did is he put two of them together. So w1 x1 plus w2 x2 plus b, the bias, combine this together is going to be y, number of hours it's going to rain today. Okay, so this is a frogs croaking, this is a sky darkness, and put proper coefficient and the bias, this is called bias. He could combine this both data together. Okay, then he can predict much better now. Okay, now if you combine this together, what's happened is probably number of hours rain and x1 x2, one is a positive correlation, another is a negative correlation, right? And if you put them together, it's become probably let's see, this is gonna be, let's see, this, it's cross here, so this, if you add them together over here, but you change the scale w1 w2, so it's going to be like somewhere like let's see, let's see, somewhere like this. So x1 x2, that means when frog is noisy but bright sky, it's hard to say, it's get close to this, I think this has a slope, right? So this graph is not right, you have to make a 3D graph actually, because x1 x2 you cannot put it on the same but still linear. Okay, And what happened is this one, he adjusted W1, W2, and from experience this data, and B, he predicted Y. So this is gonna be x1, x2, and x1 on the slope. X1 is going to be positive correlation. X2 is going to be negative correlation. So it's kind of the tilted plane, right? And it show you if frog is quiet but sky is dark, there's still chance of rain, but it may not rain. It's very hard to say here. It's kind of spread in this area. This spread in this area. Okay, so the mathematically in the AI, what we do is we take final y, sigmoid function y. And what sigmoid function is, suppose you have y result, okay, then decision making point is here. You multiply sigmoid function like that. So final decision is going to be slightly over here is going to be very positive, yes. Slightly over here is very positive, no. Okay, so it's help you to make a decision clearly, emphasizing it's a positive side or negative side. Okay, so you apply this one. So what happened is this is still linear. Somewhere its cross point of this 0 is going to skew the plane into positive side and negative side, and this is a plane. I hope you get this part. Whenever this linear plane, this is the linear plane. Linear plane is touching down this plane, right? This plane is skewed into curve like that. Okay. Why this is important? Well, actually, it's come to the first equation is going to be here, w1 x1 plus w2 x2 plus b equals y. Say this is y and this is x1 and x2. The human brain give x1 x2 and put them together, create a y. Okay, and we don't have this part yet. And this chart is a neural network. Neural network, if you add more third parameter, it's going to be added here too. And output not only the wetness, the rain, how many hours it's rain, it's a wetness. Wetness, if you want to know more other stuff, you can create equation here. And it said hidden. Why it's hidden? Because that's going to be the final decision to make. Output is the final decision to make. So we utilize this result to make the final result. In this example, say wetness, he thought some seeding, the not too wet, not too dry. Okay, and a little bit watering is good to soften the soil, but so it's not too dry, but too wet, the seed is gonna wash out by the water, so it's not good. So the best part is kind of from going back to frog croaking somewhat, and sky is dark somewhat, this area. So this is very difficult to show number of rain, and let's see, x1 say is like that, and x2 make like that, right? So decision making point, here's a wet, it's dry, this is going to be emphasized like that by sigmoid function, and this is going to be emphasized like that, right? So if you create y1 and y2, the second stage over here, use y as an input, so it's going to be another w1 y1 w2 different coefficient. It is going to be good seeding timing. You can start seeding, so it's going to be this range. Okay, so you want to have a nice range for good seeding, and you use second level decision making based on frog croaking and others. So here what he did is y1 equals w1 x1 plus b1, and y2 equals w2 x2 b2, and this is a linear function. And second level, he did this w1 new coefficient plus b dash. Okay, so that gives his final seeding time. So it's a two-stage decision making. Okay, and this is called deep AI, and you have to figure out w1 w2 and b, and here w1 w2 and b prime. So you have a two-stage of equation to reach the final. Okay, and to figure out what kind of coefficient is the best for this system, and that is called machine learning, the AI training or machine learning. And by repeating this prediction process, we determine this w1 w2 b1 b2 and this guy, and this guy. Then only things you need is frog croaking, how noisy it is, and sky's darkness. And having those both, you can get the final. And in the middle, we apply this, actually y prime, y1 prime is sigmoid function x1, and
y2 prime is sigmoid function. Sorry, this is y1 and y2. And as I said, the sigmoid function is something like this way. This is a center point to make a decision, and if you are this side, it's bring it to clearly this positive decision. If this side, it's bring it to negative. It's just like close to this step function. Okay, so it's make a clear yes or no type of decision. That is y prime, y2 prime. y1, y2 is kind of linear, you know, around the decision making point is kind of very tiny difference on decision making, and that's going to be emphasized by sigmoid function. And using that emphasized decisions, you create final decision. Okay. I'm going to use a different example here. Suppose you have 8 by 8 grid, and you write a number here like 3, right? And this number line, handwriting number, hit certain box. Okay, so you serialize this box. This is 1, 2, 3, 4, 5, 6, 7. There's 256 box. X1 is one of 256, and use the X1, whichever hit the box, you make a matrix X1 to X256 ij. Then you decide this number is 3. The possible answer is 0, 1, 2, 3, 4, 9. So this is handwriting recognition. And by training this, we hope we can recognize this handwriting in the same method. By observing the frogs croaking, we figure out how, and this is statistical too, because depending on person, they write all kind of different way to write a 3. Like they may write 3 on left side, and right side is all empty. Now, question is, how much you can predict well? Any handwriting in this box, you write, say 6, then it's recognized. It's okay, answer is 6. You cannot do very good job for one stage. So what you do is, instead of coming up with this, you come up with number of 0 here, the circle, and 2 circle here, and horizontal stick and vertical stick, so and so. The future of this number, how it look like. You detect this first. Okay, there is a circle, right? Then this circle is detected, one, and the stick, and the round stick, this part, the future is detected. Okay, if 9, this 8, probably 2 circle detected. This guy, 9 is 1 circle and 1 vertical stick. Okay, so and so. So rather than going directly into recognize a number, you go this stage, and using this, you have 1 circle and 1 stick. If this come out, then next stage, this future vector and the second level matrix is going to predict 0, 1, 9, and this does much better job. So you have a 2 stage, and actually think about it. The human look at the handwriting, they don't immediately goes, okay, this is 3, this is 4. The human brain neural network recognize the future of handwriting. So like this one, this is a 2 angle, 1 angle line with 1 stick, then recognizes as a 4. So it goes through at least 2 stages inside the brain. And the same thing, we detect the future of its 1 is just 1 particle. Only 1 particle come out in the future detection. This is not detected. Then from here, 1 particle or 0, it's going to be 1, right? So handwriting recognition, AI, it essentially works the same way as this farmer's whole AI system to predict the wetness level and best time for seeding. So this is basically linear matrix equation, but between them has sigmoid function to skew, help decision making. That means decision point is going to be abrupt decision, yes or no kind of process, and that helps to make a final decision. So it's basically same thing. It's what is AI? Okay, the handwriting recognition, that's pretty famous AI. Nowadays they can do like a 99% accuracy. How they do it? Basically doing this way. This graphic point and linear equation is going to tell you there is a circle stick, angle stick like a 4, 2 angle stick, or 7 is 1 angle stick. It's kind of difficult to say. And if somebody write handwriting, this is 9. Well, human eye, this doesn't look like 9. But AI may say, yeah, 1 circle, 1 stick, it must be 9. He meant to be 9, but maybe he didn't mean it. So there is still some statistical factor there. So it's not 100%, but pretty much it can detect human handwriting by this method. You detect the future, and the future is translated to actual final number addition. Yep, he wrote 9 here. Well, probably this is 9. Some people write like that. It's look like, is that 8 or 9? I mean 6. So there is some statistical factor there. But 99% of time, the AI can recognize the human handwriting number, basically using this system. is the same as these farmers predicting the best time for seeding. Okay, so
AI can be used for many other stuff.
the farmer to find the best seeding timing, the graphic recognition to recognize human handwriting. If you expand this to all the alphabet, it's quite a big matrix. But basically,
You can recognize the entire handwriting.
okay, so
Since AI is neural network, neural network is just a linear equation. Using this linear equation, cascading it, you can have a deep AI, deep thinking. The human when human recognize something, it has several stages usually going through and conclude the final come to the final decision. This conclusion doesn't come from the first observation. In the brain, it goes through analysis. They call analysis, but actually it's the neural network linear equation stages going through. So using this model, human brain neural network is pretty close to cascaded linear function. And cascaded linear function, you can use almost anything. And that's why AI is very powerful, because it's not just pattern recognition, voice recognition too. The voice recognized by future of the sounds like consonant, vowel, and combine them together and determine what you said. You said the bat, or you said bed or bat. It's a slight difference, but it's distinguished them, and voice recognition is done. So as I said, AI is not artificial intelligence. Is not like a robot brain. It can do everything. No, it does each specific AI task. The pattern recognition, voice recognition, and AI for improving certain productivity. Or for example, the bank loan officer need to review the person's lending history and the credit level and current job, income, so many parameters they have to look at and approve the loan. Now they are saying make an AI model and refine it. It does a better job than the human. Now that means the loan officer is going to be replaced by AI, by bank, because they take the statistics, and AI approved loan rarely default. The human approved loan has more default. For bank, AI is better than human. And this is like a computer came into our life, and computer is better than typewriter, right? So typewriter is replaced by computer. So the same thing happened. So that's why it's changed the society. The AI is going to change the society because they invent many different AI, and this AI is going to go everywhere. So what kind of AI you can create? You can create your own AI, actually. You just have an input and decision making point. Between them, you cascade linear algebra, is a matrix calculation. Then you can have decision making AI system. Okay, so this is the basic of AI. I hope you understood this, so that when some people say AI, you know exactly what it is. There's no such a thing like a Terminator robot thinking everything is a human thing. No, it's not that level yet. It's AI. It's Chat GPT is basically the you are typing, or nowadays they recognize voice, the input, the search, all the literature, and just like a Google search, they do the search for you, and they pick up most proper content and use it as an answer. Okay, so depend on what kind of database ChatGPT has. If it's very for example, racist contents, you train ChatGPT with very racist content, ChatGPT become racist, because answer is always come from the racist writing, literature, article, right? So it's AI is very artificial things. It's not like a universally, or AI is smart. It's not everything. It's answer you correctly every time. No, it depends on how you train AI, and AI training is called machine learning, and that's the most difficult part of making AI. How do you determine the coefficient W, IJ, and the bias BI? That's the most difficult part of AI development. And in order to train AI, they need a lot of data, feeding that data through and adjust W and B coefficient and try to make it best fit. Okay, and that's why the auto driving need that data for driving, a lot of data and feeding through, so that all the AI model coefficient is going to be adjusted down to the best coefficient, so it won't hit the people while driving. Okay, so that's a very basic understanding of the AI in this second video. And if you like, please subscribe and click like, and wait for the next video. We start talking about machine learning. This is a very difficult, mathematically very difficult subject, and there's no established way to do it. Every AI need to have its own solution, and that's why AI need a lot of brain to develop. There's no single AI in this world. There are many different specific AIs existing. Okay? So see you next time.